at University of Leeds. So the topic I was given today is about talk about some methodological choices in the LCA life cycle study of asphalt recycling. So a bit about myself. My background is civil engineering, highways. My PhD is about life cycle assessment of use of recycled materials in asphalt pavement, which I did in the UK. I finished in 2007, and I went to consultancy for some years, and then I did a year postdoc at University of Nottingham, which really I appreciate the experience. And then I started an academic job 6 years ago, and that's what I've been doing since. So I'm just recap on what Alisa said about this life cycle assessment. The purpose of it is to identify the high impact areas in a product or in a process. And once we identify the high impact area, we'll be able to prioritize our actions for reducing the environmental impacts. So if we look at a complex system, it involves many products and processes, and the LCA is a useful tool to help us to focus our research, the resources we have to focus on the product or the process that will make a real difference to the environment impacts. So either these processes are largely equal, like the aluminium can, or it's predominantly focused on one product, like the manufacturing of the newspaper. The LCA is a useful tool to help us to make that decision. And the second point about LCA is it's a multi-criteria analysis. And so we may have we may compare design A to design B, or product A to product B, and we may have the inventory results may be different across the 12 or 13 impact categories. And so if the difference between the two products are not uniform across the impact categories, we need a method to help us to make a decision of which product or design is better. Then the third stage in LCA that Alisa introduced, the impact assessment, is help us to make that decision. But this is example by the Build Research Establishment some years ago, and this is based on expert opinion, and it's not based on science. So for that reason, it's optional process in the LCA. So my main task, I think, today is to talk about the methodological choices in the LCA study. And there are three things I want to talk about. The first is the functional unit. When I teach the subject to students, I use some simple examples to make my point. So the purpose is that people understand that we need to create a level playing field when we compare the different products. So the first example, when we compare the packaging for the beer, we need to make sure the volume is uniform. Sorry, went back. And the second example, when we compare the currency, of course, we need to make sure the value is uniform, but also in the second example, we have durability issues. If we use the paper note as opposed we use the coins. And the third example, for hand drying, we need to think about what is the function for the product. It's not the device itself, but its function is to dry the hands. So and also the product is not just about the device itself. The first example, it used electric power, and the second one used either paper or a towel or textile. So these consumables need to be included in the life cycle studies. And after that, I come to the pavement. We have this multi-layer construction, And in the UK, we use 40 kilonewton as the design load. And so we need to think about what is the function for the product is to design to take the number of traffic. So when we compare the methods as plant recycling as opposed to in situ recycling, or if we compare different recycling methods like hot recycling or cold recycling, we need to think about the durability and the design traffic for the product. The second topic is the allocation method, is where we have a process like oil refinery. It has many different products, and we need to think of a way of how to attribute the impact and the emissions, the energy into these different products. The ISO 14040 give us three methods. The first is the physical properties like mass or volume. Now, if we do that for the bitumen, and it will be penalized because it's heavy and relatively inexpensive compared to other products from the refinery. Or the second way is the energy content, because they all come from the oil refinery. The trouble is many products like bitumen or plastic or wax, they are not used for energy purposes. So the energy content doesn't mean anything to them. The third method is the economic value, because at the end of the day, it's the market price that determines the value of these products. The drawback of the third method is the economic value. The market price varies with the time and location. For the taxation, because of the taxation, the cost of petrol in the UK is 3-4 times that in the United States. So it's not science-based. We did some work in the past that we found that the allocation based on economic value, when we use byproduct from other industries in the road payment, is appropriate compared to other methods. And the main reason is, like I said before, like most other construction product, the material we use in road building is relatively cheap and heavy. So this method will give us a fair assessment of the environmental impacts used in payment. And some people use a combination of both, like in the Eurobitumen case study, 2011. It's an association of European bitumen refinery. When they do the oil extraction and transport, they allocate the impacts based on the mass. And during the refining stage, the allocation was based on the economic value. And so that's what they did. But also the same report gave assessment that for example, the CO2 emissions of bitumen would be 23% higher if the allocation was 100% based on mass, or 45% lower if the allocation was 100% based on the price. And the method it used to give us this variation is called a sensitivity check. And it's a useful method to help us understand the impact of methodological choices we made in the LCA study. Another allocation is at end of life recycling. Elise also talked about this in her talk. It's when a product can be recycled or reused somehow at the end of its design life, then the credits can be either given to the producer, in which case the method is called a substitution, or it can be given to the user downstream and to whoever used this product at the end of its design life. And that method is called the cutoff. So, and of course, people can choose somewhere between them. For example, the aspect, it's asphalt carbon calculator developed by the UK Highways Agency. In that report, it take this, it's somewhere between the substitution and cutoff. It's not 50-50. It took a 60-40 split of the credits. So 60% credits was given to the producer and 40% given to the user. And in our analysis, and you see in the bar chart and below, we think for asphalt product, the substitution is probably more suitable. The logic is that the end-of-life scenario for asphalt product is relatively simple. It usually stays there. It can be either reused or recycled or downcycled, but it rarely goes to landfill or goes through some open loop recycling used by another industry. So we thought the substitution method is most suitable, but it's our opinion. Then the third question is the boundary, the system boundary in life cycle assessment. We have these three types of boundary. Traditionally, people use gate to gate. You know, they only look at what happened in at the plant, which is not right. So most LCA studies so far, they took this cradle to gate approach, which trace all the way back to what happened in the quarry, but it rarely go further after the product leaves the plant. But some take the approach like gate to cradle to late, so from the quarry to when the pavement is built. But the challenge of take the third approach, the cradle to grave, is that there's a level of uncertainty once the pavement is in service. However, the system boundary is important because it's not just what process we include or exclude, but also where we set the boundary to some extent determine the allocation method we need to use. So this is example I did in my PhD. I made it clear what process I include and what process I exclude. So people can agree, people can comment on it, or people can challenge. But bottom line is it needs to be transparent. So finally, I want to just mention some challenges I think the LCA of asphalt pavement is facing. One of them is that LCA is dealing with a large number of data, most likely from different sectors, the energy and transport, materials, and construction. So this is the example of LCA study I did before. I need to source the material from all these different places. Some are primary, so like what materials we use to make the asphalt mix, how far the lorry traveled. Some are pretty standard. There are standard industry data we can use. And compared to building and cars, and the road pavement is the structure and the materials is relatively straightforward, but occasionally it will involve a complex process. For example, for reinforced concrete pavement, we have the steel bars, reinforcement bars involved. And if we use pipe product from other industries, like GGBS or PFA, we cross the boundary of other sectors. We need to deal with allocation and the boundary issues. So there are some commercial tools available for us. And my feeling about these are really mixed. There are some examples like Gabi or SimaPro. I used both. They really speed up the process of analysis, and they save us a lot of time because they have sub-licensed database, and they facilitate the communication between people working on the same product, same project. So it's good for consultancy work, but for research, we just need to be careful because the boundary, the allocation method they use may be different to what we used in our study. And we are now entering a stage where the new construction of road is few and far between. So the main task is to looking at the asset we have. And so we really need to communicate effectively with engineers and who do the site work, collect the data, that is really useful and actually is crucial to help us improve the accuracy of our LCA study. So for example, the people use the deflectometer to derive the stiffness of the materials, and based on that, we calculate the residual life of the pavement. We do the coring, where we can get the materials for lab testing, and we do the deflectometer, the penetrometer, that we can get the strength of the foundation. So we really need these inputs from the people work on the site. And another challenge is that for road maintenance, we almost always looking at the lane closure and diversion. So we need the traffic management expertise. So this is an example I did again a few years ago. It's not long. The road is only 720 meters, but it involves a priority junction. So the traffic management is quite complicated. We get the expertise, we get expert who do the traffic management, and based on that, we simulate the traffic movement during the road network. And we also try, the road section is this bit, so that's 720 meters. We also try close the road completely, or theoretically for 24 hours, and let all the traffic go through this diversion. And we see what additional emissions we get as a result of that. So the point is that to complete this study, it drew expertise from 3 universities, and the contractors and the road authorities, they made in-kind contribution to the research. So in the future, how we get these resources to carry out the study of a similar like is questionable. How we get these resources, we need to find a way of carry out the LCA study more effectively, more efficiently. And the final point is that like building, the majority of emissions and energy consumption not come from the construction stage, but come from the use stage, when the number of traffic, the vehicles using the road in the long design life. And there are a number of studies in which people looking at the relation between the rolling resistance and the pavement type. So they test the rolling resistance of vehicles running on different types of pavement, and eventually they link the rolling resistance to the fuel consumption. So we don't have to reinvent the wheel, but we need to think of a way how we integrate their findings into our LCA study. So, and never forget that the electric vehicles and autonomous vehicles is not far in the future. So we really need to think about, because the payment deterioration model may change as a result of those new emerging technologies. So that's all the points I'm going to make. And thank you for listening, and welcome your questions.
Thank you very much, Dr. Huang. Very good presentation. We have a couple of questions. We'll only have time for one question. So I'll email you both questions, but for now, I'll just ask you one question. And the question is, Dr. Huang, I have a question that nowadays, most of the current impact analysis of pavement LCA is not thorough enough. Usually the results of assessment show a list of pollutants data rather than impact they cause, such as converting CO2 emissions into an index to describe greenhouse effect. What do you think is the cause of this situation, or why do you think people are using LCA in that direction rather than as the question listed, showing the actual pollutants data and the impact?
Are you is the question about why people focus on one aspect, like
correct?
Yeah. Okay. The LCA is a useful tool, but in the meantime, it's time consuming, and it requires for a lot of resources. So I can understand why people choose, look at only one aspect, like CO2 emissions. It's probably driven by either commercial or business or political reasons.
Okay, Thank you very much. Yeah.
Yeah, I can see where it's coming from, but like I said, I think Lisa mentioned about this. The danger of going through a footprint is that there's ignorance of this trade-off between different impacts.
Right.
And on a science basis, we need to look at the different aspects, but how people choose to use our findings, it's up to them.
Thank you very much. And again, I will email you the other questions that we have, and then you can respond to them. And as you graciously said, other speakers, if they have questions, they can also email them to you. So next we have Dr. Amlan Mukherjee from Michigan Tech University, and he's going to be making the presentation. Whenever you are ready, Amlan, go ahead and share your screen. You already have the rights to do so.